What we're going to do in this experiment is add a certain number of grams of calcium chloride, and I've got the beaker set up here. I'm going to zero the beaker. I'm going to shoot for somewhere around 1 gram of calcium chloride. It has to be precise measurement. It doesn't have to be exactly 1 gram. I'm going to start out with this much calcium chloride, and I'm going to add some water to it. The water is just a catalyst. The water has absolutely nothing to do with the reaction. It just helps the reaction along. Once it's all mixed, to this solution I'm going to add some clear, colorless silver nitrate. Silver nitrate is AgNO3. Ag, silver, has a +1 for a charge. We're going to add this to the calcium chloride until it reacts. And we'll let it sit and settle. After allowing this to settle for a few moments, this is what the solution looks like. A solid layer with a liquid layer on top. This is a piece of filter paper weighed out to the nearest 1/100th of a gram. We're going to filter the solid portion out and get rid of the liquid portion through this piece of filter paper. This is our filtering apparatus. The piece of filter paper goes in here, and as we turn on the water, it's going to suck our solution through, and so our solid will be caught in the filter paper. Now I'll take a wash bottle and make sure that I get all of my solid out of this first beaker. The wash bottle is just water. This is what the top of the filter paper and product looks like. I put the filter paper and product in a drying oven overnight to make sure I don't weigh any water mass. I only want to weigh my product. And this is my final mass of the filter paper and product. When weighed again, the mass of the filter paper and product weighs 3.05 grams.
anyone here know what a spectrophotometer is? Have any idea? Okay, it's designed to measure the wavelength and amount of electromagnetic radiation absorbed and transmitted by a sample. Each sample has its specific unique spectrum, and a color is emitted also. Okay, you can have those sheets now. Okay, the sheets just show facts and objectives of the spectrophotometer and what we did on our lab. Okay, the first objective is to obtain information about atoms, molecules, and ions. The second objective is to learn how to use a spectrophotometer. The third is to observe the effects and different wavelengths transmitted by the light using samples of water and chalk. And we'll show those to you in the spectrophotometer, and you can see the colors emitted by different wavelengths. 4 is to adjust the spectrophotometer to measure the maximum phototube response in water. 5 is to identify how the spectrophotometer selects narrow bands of light correlating with the wavelengths of color using chalk. And 6 is to graph the overall response to the phototube response as a function of a wavelength. Okay, should we show them the parts?
Yep.
Okay, this is a spectrophotometer.
Alright, this is what a spectrophotometer looks like, and here are the parts of it. And I'll just explain to you so then you know, because make sure you follow along carefully, because at the end we will be giving a test out. Alright, first of all, right here we have, it's called the right front knob, but we refer to it as the RF. And then along here is a left front knob, but we also refer to it as LF. And for the left front knob, you turn it on. And here's the absorbance scale. And then right here is called a percent transmittance scale. And what it does, it just shows a percentage of it. Along here, this little compartment right here is called the sample compartment cover. And what that is that's where you put all your ingredients or what you're experimenting with. And right here is called the wavelength knob. And that is you see this little circle right here, it shows your numbers. And you turn this knob to turn what numbers you want on it, and then it'll show you your percentage scale and what your percentage is along with the numbers. Okay?
Yeah. Should we go through this lab now?
Okay. Now we're going to go through the lab. We'll have Thane do it for us.
And you can come up and look at the different colors on the chalk. Let me get to that part. We're just going to do the chalk, right?
Mm-hmm. Yep.
So you can hold on to it.
Just the chalk part. We're just doing chalk.
Just doing chocolate? Oh, yeah.
Because the water doesn't really show any color, so it won't be real interesting to watch.
Okay, before you put it in though. Okay, we got to turn the knob at some degrees. Okay, with the sample compartment empty and the lid closed, adjust the LF knob so the meter reads 0% transmittancy. So can everybody see?
Everyone can just come up here. Is that all right?
You can just gather around. Okay, can everybody see right here that it's at 0%? Because this is our transmittancy scale. Okay. It says turn the right front knob, the RF knob, okay, fully counterclockwise. Okay.
Oh, was it counter?
Yep. Yeah. We're gonna do the one with the water too. Fill it halfway. Because we'll just do that first. Okay.
The whole thing?
Yep. After turning it counterclockwise, it says fill a half-fill cuvette with distilled water. Okay, before putting it in, adjust the wavelength knob on the top to read 510. So adjust the wavelength knob for 510 before putting it in.
510?
Yep. So then, can you guys see up here? Okay, so look, and this is a 510 it's going at.
You aren't supposed to touch it with your fingers.
No, because then it'll show. Okay, now number 4 says adjust the wavelength knob on the top to read 510. Has that. Now adjust the RF knob until the meter reading is 90%. So we're going to keep adjusting the RF knob, which is right front knob, until this up here is 90%. Okay? Can everybody see it? And the highest transmittancy we got was 510. Now it says adjust the wavelength knob to the highest transmittancy value recorded in step 5. Then adjust the RF knob to read 100%. So now we're moving it up 10 percentage. Okay, does everybody see that? Okay, now you can remove that one. And we're going to remove it with our Kleenex again because we can't have fingerprints on it. Otherwise, it could take our numbers off value. Now we're going to use it with chalk. We had to use a 3 centimeter chalk. And it says with chalk still in place. Now, okay, you removed it. Now we got to put the chalk in. Was the sample compartment open? So put it in the compartment. Now we have to
Should be at
twist.
0 or?
It's
No?
fine.
Okay.
Now we have to twist our chalk. And then until you can see a light striking the chalk. And okay, can you see a light?
Mm-hmm.
Okay, now we want to observe and record our color light, which we do on our charts, and I'll explain that later. And from 350 to 650, there will be light containing. Do you want to do that thing? So then, like, get it at one color and pertaining. Like,
You don't have to show them all the colors.
no,
You
put
just-
it on green. Find green.
That's was that.
That's 5.
Yep.
5 to
So
5.
now Thane will put it on 5 under the 510, and you guys can all go look inside and see what color it is. It's green. Okay, is that in there? Okay. And if you realize the lower numbers don't have anything, and then when you get to the 400s, it goes to violet, and then when
It's
you
like right on the side.
as you go on, it kind of goes backwards as Roy G. Biv as the rainbow colors.
And the reason that the first colors don't have any, or the first light doesn't have any colors is because the electrons aren't excited enough. And the numbers aren't high enough, and as like numbers get higher, the colors progress.
Yeah. Okay, then you can just go back to your seat when you're done. Thane, did you give Mr. H a sheet? Okay, give him that when he's done.
Is that it then?
Yep.
That's all.
Okay. Now I'm going to explain to you our charts. Okay. First of all, here's our chart, and it's just kind of like what we just did our experiment. And as you can see, the 350, the 375, and the 400 have nothing, and that's because the electrons didn't get excited enough. And on here, it goes from the backwards rainbow, it goes Roy, G, Biv. This B is supposed to be right here, though. So then, okay, 425, the color was violet, and that was and the RP was 98. And what RP stands for, it stands for the phototube related response, and the RO stands for the overall related response. So then, the RO was at 48.5. Well, then we went to, it got to indigo color, and the indigo color was at 450. The RP happened to be at 91%, and the RO happened to be at 68%. Well, then there was a 475, which turned out to be blue, and RP was 81%, the RO was 85%. 500 was green, was RP was 68%, the RO was 97%. 510 was 61% and 100%, and that was green again. And the most colors happened to be was green and red. Then we went to 525, the RP was 53%, RO was 97%. 550 was 37% and 76%. 600 was 10% for the RP and 21.5 for the RO. And your final number was 650, and RP did not have any color in it at all. And the overall percentage was 4%. Now here's a graph showing the resemblance, or so you can see how it went. And the graph says responses of the phototube and overall the wavelength in nanometers. Here's the nanometers, the number going from 50 to 750. And here's the RP and RO going from 10 to 140. RP standing for phototube related response, and RO standing for overall related response. And as you can see, the blue was RP, and the blue kind of started out high, went up a little higher, and then dropped right down. Where the RO, overall related response, is red, and it started out low, went up high, and quickly went down again. Okay.
Okay, now can you put away all your sheets that you got?
Just have them put everything on the
Danny,
floor.
I'll need the sheet too.
Yep. Then you can just
Put
like
the stuff on the floor.
put all your books and everything on the floor and only have a pencil remaining, please.
Of a
It's for
drawing.
overall too, but you had half. You had about 75% right.
Okay, the second one. What is like one of the purposes or objectives of the lab? It was on your sheet. Can anyone remember one? Lee, we can't call on you again already. Does anyone else know like one of the objectives? Or a purpose for the lab? We went through them at the beginning. Alan?
Do you know? Yep.
Okay, sorry. Okay, number 3. Explain why the band of light, like a band of light, it would get dimmer and eventually fade away when the RF knob was turned counterclockwise. Lee?
So decreasing the percent.
Yeah, and like when you decrease the number, the electrons don't have so much energy in them and stuff. There you go. It's for Lee. Well, nobody else raises their hand. Yeah. Okay. Number 4 is on the chart which color shows up the most often. Danny. Yep. It really is. Yeah. It's more so the green than the red because the RP on the red didn't show up. But that's right.